Okay, start with number 66. And with number 66, the question reads, which of the following categories includes the majority of the elements? You have your periodic table, which I don't care how I draw it, whatever. It's a mess. You're going to find out there's a division over here that separates metals and non-metals. Those that run along this division are called metalloids. And with metalloids, that's this section right here for the most part. These are your non-metals. These are your metals, including the lanthanide and actinide series. Lots of metals, very few non-metals. So the answer for that one for 66 is going to be C. Number 67, what element has the configuration of 1s2, 2s2, 2p6, 3s2, 3p2? Hopefully you had that right. So you're going to the P section. I'll use this one up here. The P's are over here. You're going 3 down, and it's 2 into the P section. 3p2 is going to be ultimately silicon. The answer is C. Number 68. The subatomic particle that plays the greatest part in determining the properties of an element is not going to be what's inside, but more so, and those are your protons and neutrons, it's going to be the electrons, and in particular, it's going to be the outermost electrons, your valence electrons. That will determine whether they give up electrons, take in electrons, share electrons. That denotes the properties. So we're looking at B for number 68. If someone marked it wrong on any paper, talk to me later. I'll probably ignore you. All right, number 69. How does atomic radius change from top to bottom in a group in the periodic table? The key is going to be this. For the next few and on your final, as you go up and across, I told you to remember atomic radius. As you go up, the radius of the atom is going to get smaller because you have less energy levels. As you go across, it's also going to get smaller. So up and across is decreasing for atomic radius. All the others are the opposite. So therefore, up and across will be increasing for things such as ionization energy, electron affinity. What else was there? I don't know what the other ones are. We'll get to it. So the question is, how does the atomic radius change from top to bottom? They tell you the direction. You're going from the top to the bottom. So therefore, I'm going down. Well, if this says going up is decreasing, then going down is increasing. So 69, it tends to increase. The answer is B. Number 70. How does the atomic radius change when you go from left to right? You're going in this direction, which is what we showed here, what I've shown here already. It's decreasing. So the answer is A. It tends to decrease. Number 71. What causes the shielding effect to remain constant across a period? Shielding effect is the effect that you get from the protons that you have in the nucleus to the outermost electrons. Shielding is going to be this stuff right here. The more shells you have, more energy levels that you have, the more shielding is going to be. But as you go across a period, you're not getting a new energy level. You're staying in that energy level. So therefore, you're adding another one here, another one here, another one here. Shielding isn't changing. If you went to another level, yep, more shielding now, this one. So shielding, I think my analogy a long time ago was being a goalie in hockey, being screened by other players. They're in your way. Well, if you have a player that's directly in your way, that's a problem. If you add another one to the side of him and another one to the side of him, big deal. They're not in your way. They're not affecting you. So shielding is going to be based on what we call core electrons. And core electrons are different from the outermost, which are what? Thank you. Valence electrons. So number 71. What causes the shielding effect to remain constant? A. I'm sorry, no, it's actually B. Electrons are added. Whoa, what causes the shielding effect to remain constant? answer is A, actually. Electrons are added to the same principal energy level. The answer is A, actually, for that one. So I messed up. I gave you B, I think. I apologize. I'll give you a point. 72. Highest grade was an 85 now. 72. Atomic size generally decreases as you move from left to right across a period. We saw that earlier. I can move it up. We saw it earlier here, decreasing left to right. That's a true statement. 72 is D. Number 73. What element in the second period has the largest atomic radius? Well, what we said with that was going to be, as you go across a period, you are decreasing in size for atomic radius, so therefore the larger ones are to the far left. Out of all of these, the one that's furthest to the left is going to be B, lithium, which is way over here versus others. So answer for that is B. 74. Which of the following elements has the smallest atomic radius? Once again, smallest is going to be based on as you go across, it's getting smaller, and as you go up, it's going to get smaller. So when I look at the relative locations of, here's sulfur, for example. The next choice is chlorine. When I compare these two, they're in the same period going across. Sulfur is larger than chlorine, and we're looking for the smallest, so chlorine would win so far, but we're not done. Then we have selenium, which is right here. Well, that is an extra energy level. That's not the smallest. That by far is the biggest right now. And then after that, we have bromine, which is over here. So therefore, the smallest would be the one that has the fewer shells. So that's out of here. And as you go across, it gets smaller, smaller, smaller. Chlorine's your winner. The answer was B. Number 75. So if you don't remember your trends, you're going to have a hard time. Memorize the trend. If you remember atomic radius, the others are opposite. All right, what is the charge of a cation? Well, there's my cat. They're positive. Cations are positive. So the answer is A. Positive, someone in the future says. 76. Which of the following is true about ions? All right, the answer for this one is going to be B. Cations form when atoms lose electrons, and that is true. An example would be something like magnesium. Magnesium has an atomic number of 12. So it has 12 positives, 12 protons, 12 electrons. It will lose electrons. So magnesium loses 2. It's down to 10 electrons. Overall, this has 2 extra positives, a +2 charge. That is a cation, and that is what a cation does. So 76, the answer is B. 77. We're looking at groups 1A, 2A, and 3A. On my periodic table deal, those are the ones, it's 1A, 2A, and then 3A is over here. These are B's, and we don't care about those, at least for this. What's true about them? They gain electrons to form ions? No, they don't. Groups 1, 2, and 3, if I look at, for example, the ones in group 3, being in group 3 tells you have 3 valence electrons. The choice to get filled outer shell would be, you could add 5, or you could remove 3. Remember that choice? We take the lower number. We're going to remove 3 electrons. So something in here, it used to be no charge. You just got rid of 3 electrons, so there are 3 positives that are not canceled out. They have a +3 charge. So for 77, what's true about it, they lose electrons and they form ions. They don't take them in. They don't form all negative. No, they're going to be positive. And they don't all have a +1 charge. This row, this column has a +1. That's a +2. That's a +3. So that one doesn't apply. So 77, answer is D. 78. Which of the following Which of the following statements is not true about ions? When you see not true, you're looking for the false statement. Cations are positively charged ions. That's true. That one doesn't answer it. B says anions are common among non-metals. Well, let's go back to what I drew before. Something like that. I said these were your non-metals over here. And most of these are like -3, -2, -1. They're negatives. They're anions. So that's a true statement. We're looking for the false statement. C says charges for ions are written as numbers followed by a plus or minus. That's true too. D says when a cation forms, more electrons are transferred to it. Nope, they're transferred from it. A cation is positively charged. The only way to be positively charged, get rid of some electrons. D says it's taking some in, and it's not. I'll make it negative. So 78, the false statement is D. 79. In which of the following sets are the charges given correctly for all the ions? When I look at A has Na plus 1, Mg plus 1, Al plus 1. Is that true? Is that what they are when they fill up their shells? No. Na is, but these are not. B says K plus, strontium's 2 plus, oxygen's 2 minus. Is that correct? Potassium, strontium, oxygen, that is all correct. Therefore, so this is the only one that does apply. Therefore, for 79, the answer is B. Moving on to number 80. 80 reads, which element has the highest electronegative value? Same deal again. Go across like that. Electronegativity is going to increase. How do I know that? Because I know normally if I do this, atomic radius decreases. And I said if you know the atomic radius, you know the others. It's the opposite. So therefore I follow that rule. In 80 I should end up with fluorine, which is up here. Fluorine's about there. It increases going up and it increases going that way, and that's kind of where fluorine is. So for number 80, the answer is D, fluorine. 81. Group 2A, which electrons are the most difficult to remove? So, I'm only going to show the very end over here, first, whatever. Here's the group 1, here's group 2. And they want to know which electron is the hardest to remove. Let's see. First, second, or third. Oh, I got that one wrong. Bummer. Is the first hard to remove? Somewhat. Is the second hard to remove? It's even easier. You remove this one, it now looks like that. You take away the second one, it now looks like a noble gas. Is it easy or difficult to remove from a noble gas? It's difficult. It's actually the third. The answer should be C for number 81. I'll look at it. That's kind of number 82. Which of the following elements has the smallest first ionization energy? Well, once again, if we look at this deal here, we have sodium, okay. We have calcium, which is like over here. We have potassium, which is over here. And we have magnesium, which is above. All right, so we have a game of 4 here. So it's Na, Mg, K, and Ca. Which one is the easiest to remove? Once again, if you play this game and you look at ionization energy, as you go up, the ionization energy increases. Does that mean it's easier to remove or harder to remove if the ionization energy increases? Harder. It takes more energy to take it off. So therefore, the lower they are, the easier it's going to be. And left to right, as you go to the right, it's harder to remove. Because of, remember the word effective nuclear charge? Well, as you go across to the right, they're harder to remove. So you want one that is lower and to the left. Lower to the left, potassium. It's the lowest one given, furthest left. So the answer for number 82 is C. 83. Compared with the electronegativities of the elements on the left side of the period and the electronegativities on the right side of the same period, what's true? Let's see. The electronegativities is what? So we said if you go this way, we're on number 83. As you go across, it is going to increase. So it says, when you compare the left to the right for the same period, are they higher or lower? The left is going to be lower than the right. Ionization is going to be lower than the right. Hence, of course, I gave you the wrong answer. I read it wrong. Let me check it though. I was right. Answer B. 84. As you move across from left to right, across the second period, what's true? Let's see, the only one that holds true is going to be A. Ionization energy increases. All the others are false. So A is your answer. So once again, you have to know that ionization. All right. Derek just threw out his gum. That's good. All right, 85. How many valence electrons are in phosphorus? Look for the group number above phosphorus. That tells you the valence electrons. We said that holds true for all the A ones. So phosphorus is group 5. It's group Roman numeral 5A. So therefore, it is 5 valence electrons. Answer for 85 is D. 86. How many valence electrons are in magnesium? Same deal. You find magnesium, and it's in group 2. There are 2, so your answer is A. 87. How many valence electrons are in silicon? 4. That was easy. 4, so the answer is B. Yeah, you can. It's still 4A. So it still has 4. Number 88. What is the name given to the electrons in the highest occupied energy level of an atom? In other words, here's the nucleus. We talked about this earlier. Proton, neutron. We have electrons in different energy levels. Then you have some in the outermost. That's the highest. That'd be energy level 1, 2, 3, 4, 5. That's the highest. Those are valence electrons. The answer is B. 89. Calcium. They want to know the electron configuration for a calcium, not an atom. If it's a calcium atom, it's where it falls, but an ion, which means it's going to fill up its shell. Calcium is going to be a calcium with a +2. Calcium is going to have an electron configuration like which element? Like argon. And argon's 1s2, 2s2, 2p6, 3s2, 3p6. And we're done. So the answer for that is A. 90. The octet rule states, in chemical compounds, atoms tend to have 8 electrons in their principal energy level. That's C. And I'm going to stop it here, and I'll do another one in a minute.